Hi everyone, in this video I'm going to show you how you can solve this cute question on permutations and combinations, which was submitted by one of the anonymous users from our YouTube community. And this question is coming from October-November 2010 series of Cambridge A-level mathematics examination. Back in these days, we used to call probability and statistics paper as paper 6, not paper 5. That is why I've written over here paper 6 variant 3, and this is question 6 for the same paper. Now the idea behind this whole video will be such that I'll be going through all of the question step by step. Then whenever I think that I am done reading the question, you can pause the video over here and then you can try to attempt the question by yourself. And then you can compare your solutions against mine and we'll also be going through the examiner report. So let's get started. In this question, we are given that a small aeroplane has 14 seats for the passenger. So if you count all of the seats, there are a total of 14 different seats. The seats are arranged in 4 rows of 3 seats and a back row of 2 seats. So we are having 4 rows and each row is having 3 seats. And for the last row that is at the back, we are having only 2 seats. Now, 12 passengers board the aeroplane. Out of 14 empty seats, we are just having 12 passengers who can fill up this kind of spaces. In the first part, which is relatively very easier for us to answer, the main difficulties that students were facing were in question 2 and question 3. However, in the first question, they are asking us how many possible seating arrangements are there for the 12 passengers, giving our final answer correct to 3 significant figures. So yes guys, just pause the video over here, give it an attempt and come back once you are ready. So welcome back if you did give it an attempt. I am sure this question must be very easier for you guys. And even in the examiner report, they had mentioned about that for the first part, it was pretty easy for most of the candidates. Only minority of the candidates did not really pay attention to the final answer to be given in the 3 significant figures. So over here, out of 14 seats, we have to arrange 12 of the passengers. So the answer will become 14p12. But now because they had specifically talked about the final answer being in 3 significant figures, this is what you should be giving your final answer in this particular format. If you are leaving your answer in this format, you won't be getting the full 2 marks. So just pay attention on this kind of minor details in the question. Now, given this, let's move on to the next question. It is given that these 12 passengers consist of two married couples. So one couple is called as Mr. and Mrs. B, and the second couple is called as Mr. and Mrs. Brown. And there are 5 students and 3 business people. So out of these 12 passengers, there are total of 4 people who are married, and 5 are students, and 3 are business people. That is how, if you count 4 plus 5 plus 3, it is 12. In the second part, they have given that the 3 business people sit in the front row, the 5 students sit each at a window seat, Mr. and Mrs. Dean sit in the same row on the same side of the aisle, Mr. and Mrs. Brown sit in another row on the same side of the aisle. How many possible sitting arrangements are there? Now, this was one of the difficult questions as mentioned in the examiner report. I'll just show you what are the comments mentioned in the examiner report. But before that, I'll really recommend you to pause the video over here and give it an attempt and then come back and check if you got it correct or not. If you got it correct, well and good, or else we'll just go through the solutions together. So welcome back guys if you did give it an attempt to the second part. And the final answer over here should be 17,280. If you did get this correct, very good. And for the students who yet did not get the correct answer, but you at least gave it an attempt, please pat yourself. Because you are at least activating your neuron and at least thinking something as compared to those students who are not even giving an attempt and just leaving this kind of questions. You are far, far better than this kind of students. So yes, for those who did not get this correct, let me explain you how we can solve this. I'll also be explaining you some of the important comments from the examiner report as I go ahead with this question. So over here, they had given us 3 business people are going to sit in the front row. So in the front row, there are 3 possibilities and there are 3 business people. So arranging them is going to be pretty simple. It's going to be 3 factorial ways. It was pretty much answered by each of the candidate who had appeared in this examination. But then comes the confusion. The 5 students each sit at a window seat. So now if the first row is already occupied, a lot of students said that now I am having 1, 2, 3, 4, 5, 6, 7. So out of 7, I'll need to arrange 5 students. So most of the students answered this as 7p5, which is going to be incorrect. I'm going to explain it to you just in a while. The next statement states that both of the couple are going to sit on the same side of the aisle. Obviously, on this side, there is only one seat. So the only possibilities for the couple is going to be either this or this or this. So out of these three, they need to select any two of them. One will be obviously empty. So let's say a couple is occupying these two spaces. So what's going to happen? How many spaces are left now for the students? So there will be only one, two, three, four, five. So out of total of five students, we are having only five spaces left. So arranging them is just going to become 5 factorial, not 7p5. So because of this confusion, a lot of students got the second part incorrect. I hope the confusion is clear to you. And now the question is, how many total possible sitting arrangements are there? Let's move on to the solution. So for the business people and the students, we have already mentioned about that it's going to be 3 factorial and 5 factorial respectively. But then what about the arrangements of two couples? So I know that there are two choices that I'll need to pick from the three possibilities. And that is why I'm first writing 3c2. Now once I've decided that out of three I've chosen two of them, I'll need to assign the couple to these two choices. That is why, because I'm having two of these possibilities of the couples, I'm having into two. Now each couple can arrange amongst themselves. Let's say, for example, Mr. is sitting over here and Mrs. is sitting over here. It could be the otherwise as well. And same can be happening over here. So there are two ways to arrange the couple amongst themselves over here and over here. So in total, there are four different such ways. That is how I get a total of 24 ways to arrange my couple. And after that, the file arrangements are simply because all of these things are happening at once. I can say that because I've exhausted all the possibilities, the final arrangements is going to become 6 into 24 into 120. And that's how I get the final value as 17,280. So I hope that this has given you some kind of an idea of how to solve this question. Now let's move on to the third part. So the question states that if instead the 12 passengers are seated randomly, what is the probability that Mrs. Ling sits directly behind a student and Mrs. Brown sits in the front row? This question is of 4 mark. Please pause the video over here, give it an attempt. Come back once you are ready. So welcome back if you did give it an attempt. The final solution for the third part for this question is 25 by 364. If you did get this correct, very, very good. But for the students who did not get it correct, let me first of all help you understand what were some of the common mistakes that students had made who appeared in this paper according to the examiner report, and see if you are falling into one of these categories. So there are two common errors made by the lot of students. The first one is, because you were asked to find out the probability in this question, majority of the students just avoided this because of maybe a lack of time issue or whatever. They did not really find the probability, but simply found out the possibilities of ways in which Mrs. Lin can sit behind a particular student and Mrs. Brown sits in one of the uh, seats in the front row. But the question was about the probability. Okay, so that is one of the common mistake. The second common mistake was a lot of students forgot that Mrs. Brown has already acquired one of the seats in the front row. Let's say, for example, Mrs. Brown is acquiring this particular seat. Now, how many ways are going to be there for Mrs. Ling to sit behind a student? So, student could sit in 1, 2, 3, 4, 5, 6, 7, 8. This is 9 and this is 10. A student cannot sit over here because behind that there is no place where Mrs. Lin can sit. So now there are only 10 possibilities where I can make Mrs. Lin sit. But our majority of the students said that they did not really consider Mrs. Brown position in the first row. Because of which the majority of the chunk of students said that there are 11 such possibilities. So that was the second mistake. I hope both the mistakes are clear to you. And now you can just comment down and tell me if you belong to any of these categories. If not, let me show you the whole solution. So first of all, let's see in how many ways we can select Mrs. Brown over here. So there are three of these possibilities where Mrs. Brown can sit. And that is why I'm having 3C1 for Mrs. Brown, that is equal to 3. And then for Mrs. Lin, I've already explained that let's say if Mrs. Brown is acquiring one of the seats in the front row, then I'm having 10 of the possibilities that I've marked over here behind which Mrs. Lin can sit. That is why there are 10 ways for that. Now, when I'm saying that Mrs. Lin can sit behind a particular student, we need to first of all figure out which of the student we have selected out of the 5. And that is why in order to select one of the student out of 5, it is going to become 5C1. That is going to be equal to 5. So out of 12 people, I have already decided where Mrs. Brown, Mrs. Lin, and this particular student is going to sit. So out of 12, if I remove 3, I'm just left with 9. And in the whole plane, there were a total of 14 different seats. Out of 14, if I remove 3, I'm left with 11 seats now. So for the remaining people whom I have yet not arranged, so there are 11 such places where I can arrange them. How many of them? 9 of them. And that is why 11P9 will be their particular arrangements. So in the question, they had asked us, now because we are allowing 12 passengers to be sitting randomly such that Mrs. Lin is sitting behind a particular student and at the same time, Mrs. Brown is acquiring one of the seats in the front row. So the total possible arrangements is going to become 14P12. That was the answer in the first part. And the possibility of the arrangements of the other people is going to become simply the multiplication of all the possibilities. That is 3 into 10 into 5 into 11P9. And then if you just simply do this division, this is the final answer that you will be getting. I hope that this has given you some kind of an idea of how to solve this question. So yes guys, that's it about this video over here. In case of any kind of doubts, please make sure to mention them in the comments. And at the same time, let's say if you understood the whole solution, also let me know in the comments that yes, I've understood the whole solution. And please don't forget to like this video because each of your like is just going to be a huge support to me. It's going to tell me that yes, I'm enjoying this kind of content where you're uploading this kind of difficult questions and its respective solutions, along with the examiner reports and what are some of the common mistakes that students have made, and then how you can avoid them. And then let's say if you want to just join one of the online live classes that I offer, you can reach out to me directly over my WhatsApp. This is my number. You can directly leave a message over there. Thank you so much for watching this video so far, and I'll see you in the next one.